All right, hey everybody. It is the 30th of April, 2024. This is Mesh PBL Live Coding. We were just talking before press and record about Builderfest last week. I had the opportunity to go to Toulouse in France and check out a really great event. And one of the things I'm leaving excited about is something that we've looked at a little bit before, is this Asteria game from TX Pipe. And we had a chance to play around with this in person, and it was really fun. That's an experience I would love to have again. Um, Watching these little spaceships move around the screen, but I guess I'm kind of getting ahead of myself if you're new to Asteria. So what it is it's a game specifically designed to help devs understand the EUTXO model. Okay. And if you're familiar with smart contracts at all, you can start to imagine how it works right away. All right. What you have is a spaceship, which is represented in a UTXO with a spaceship token. And there's datum associated with your spaceship that shows your XY coordinates on a 2D grid. So imagine you're one of these little blue ships. You can build a transaction that updates the coordinates and therefore moves your ship around the screen. And the game here is to try to be the first ship that gets from the edge of the map to the pot at the center of the map. And if you can do this, you can claim all the rewards in this pot right here. But it's a little bit complicated, because you can't just move your ship as far as you want in every transaction. Ships have fuel, and that fuel is also represented in some datum. And if you run out of fuel, you're stuck. And that's what happened to me the first time I played. I was flying my ship around, but I forgot to really think about fuel because I was having so much fun flying around the screen. And I got stuck just somewhere in outer space. In order to refuel your ship, you have to land on one of these green dots, which hold additional fuel, and build a transaction essentially where you claim that fuel. What do you guys think so far? Any questions about the essential game mechanic?
You had to consume the pod UXO. Is that the plan?
Yeah, so the challenge is to get to the pot UTXO. And the way they built the game is when your ship lands on the pot, you get to claim half of the rewards in it, right? So you can imagine the first person to get there gets 50% of all the rewards, the next person 25% of the total, and so on until the funds are negligible. So there's no diagonal motion. You can move, you can change your X coordinate and you can change your Y coordinate, and every horizontal or vertical move consumes one fuel, right? So for this spaceship to move from coordinates 1, 1 to 2, 2, it would have to go, up 1 and over 1. That's 2 moves, and that would consume 2 fuel, all right? And they start to share a little bit more details here. Okay, here's what the data might look like: your X coordinate, your Y coordinate, and your fuel. And you can see that if a ship is touching a fuel UTXO, it can claim some of the fuel from there. Ships must gather these tokens, which are distributed randomly across the grid. Okay. And you can start to see how different NFTs are used to implement the game. Now, a concept that we've covered in previous PPBL courses and that we're going to be able to cover again by looking at this game is that this is a headless application, right? Let's look at the code. And so if we look at the on-chain code, what you're going to see is that this was actually built in Aiken. Cool. All right. And we can look at, let's just first look at the space-time contract right here. All right. This is a validator. You can see the datum is a ship datum, and there's a ship redeemer. And then we've got some validation logic here about how all of this works. Okay, so first things first, I just want to notice that these contracts are written in Aiken, right? So that's the first way we'll be looking at them. And this points to a few things. First of all, one challenge we could put to Plutus PBL devs is if anybody ever wanted to rewrite these contracts in a different smart contract language, Plutus TX or otherwise. But I don't know if that'll happen, and I'm not too worried about that. What we know is the validators exist. And when they exist, we can compile them with different parameters right here, therefore creating different instances of the game. Maybe you can imagine, right, at an expert level, if we were ever going to put a game like this on mainnet with real rewards attached to it, you'd probably want to make it pretty challenging. So people really have to push to participate in the context. And there's a lot of ways to make it challenging. One way is just to make the board really, really big, right? So we could set a large minimum distance, and when we create the playing field, we could extend it for 1,000 or more coordinates in every direction. But in a learning context, right? If we're talking about beginner developers who are playing this game for the first time, one thing that's really interesting to me is putting a very simple game board on preview or pre-prod testnet where people can just play with it, make their first transaction that moves the ship a little bit, right? And learn simply. And it strikes me, this is kind of how like addictive iPhone games are built, right? If you ever played one of those silly little iPhone games, they always start with a really simple puzzle and then you move up, right, as you go along, but you're learning how to play the game by solving some simple puzzles before it gets more complicated. And I think creating something like that could be a really nice exercise for us. And when we create those different instances, now, of course, we probably want to have a front end so that players can visualize the game. They can see the results of their on-chain transactions by seeing the ship move across the screen and gather fuel and all of that. So this leads us to some really nice opportunities to play around. And that's why I'm looking at the on-chain code right now. There's more, right? Several different validators. There's some minting stuff where, yeah, I got to review the code base here. That's what I was hoping to do today. Find like the minting spaceship stuff. But also there's all this off-chain stuff. And you can see it's implemented in Lucid. So there's a Dino project that we were playing with using the Lucid libraries. And this is where our challenge comes in, right? Let's learn about each of these transactions and let's take this opportunity to understand the mesh libraries better by building similar transactions. And this is a project that might take us a couple of weeks. We're not going to finish it all today, but I wanted to start taking a look at this here. Now that I've shown some of those details, How does that sound to everybody? If we spend the next few mesh live coding sessions implementing an Asteria front end. Right, cool. So I'm not even sure where to start. I'm showing up here, just I wanted to bring that idea. But let's just review this code for a second. Create Asteria. Need an admin token to do it. And yeah, cool. This is a simple transaction, right? All we're saying is we want to pay to the contract some datum. What's in that datum is some Asteria info. And here we go. There's just a ship counter and a shipyard policy in that datum. Nice. All right, so that looks pretty straightforward, what it takes to initially launch a new game. Got some types we can look at. Datum, pellet datum, ship datum, ship redeemers. Excellent. And this is a pretty good overview right here. So here's some game datum. This looks like it's going to be the number of ships and a policy ID. Pellets, this refers to the fuel. So these would be those green dots that were on the screen in the example. And so this is a datum that has 3 ints and a byte string. An int for the amount of fuel in the pellet, its position on the grid, and here's that shipyard policy that looks like it's going to match the one in the datum here. Cool. So this shipyard policy ID looks like it's a pretty important NFT to mint to instantiate the game. Here's our ships. A ship has the same stuff as the fuel pellet, right? The amount of fuel in the ship, position, we looked at that. The name of your ship, aha, and then the name of the pilot token. All right, so what's the pilot token? This is similar in nature to like the SIP68 tokens. Or, if you're familiar with how we've done this course in the past, the Plutus PBL contributor token, where you have the one token in your wallet and the reference token at some other validator address that holds some data about you as a learner or a contributor. Similar story here. As a player of the game, you're going to get a pilot token in your wallet, and your pilot token is what allows you to move your ship token. Okay. This one goes in a wallet. This one is at the space. I believe this one is, they call it the space-time validator. Okay, so the space-time validator serves a similar role to like a contributor reference validator. Any questions at that point right here? I'm trying to describe this for the first time, like just practicing.
Yes, so that's gonna be like different tokens involved, right? So we have the ship, the pilot, and I think one more, right?
Yep. Yeah, so the ship is on the board. The pilot token is in your wallet and allows you to move your ship. And then
Okay.
the pellet tokens are going to be scattered about the game board, where people who are driving a ship can collect a pellet to refuel.
Mm, okay.
And look at the redeemers. The ship has a redeemer. And it could be a couple of different things. It can be to move, to gather fuel, to mine Asteria. We got to figure, maybe this is the winning case. I think if you're on the pot, maybe that's what this is. We'll have to look at the source code. Or you could quit the game. So yeah, as the pilot of a ship, those are the four things I can do. And when I look at this Redeemer and I start to think about the transactions we will need to build, this points to four of the transactions. A pilot has to be able to move ship, gather fuel, win, or quit. Ship Redeemer. So move ship. Right. Move ship has these Redeemer params, the change in X and the change in Y. And there you go. That would be an example of a ship Redeemer. Ship Redeemer, move ship, params. And I'm assuming maybe move ship is index 0 in the types. So we can look at the on-chain code for that. But yeah, if these are just in order, we can maybe assume index 0, 1, 2, and 3 for the redeemers. But we'll have to go look at that. If I'm gathering fuel, I just have to provide an int to say the amount. If I am mining, all right, I want to find this. I'm assuming this is the winning case, but we got to go look at the code and quit. So let's find those indexes first. This is a good chance just to navigate some Aiken on-chain code. So here's those types once again, but I don't see the indexes here. Helper functions, those are nice. Space time, this is the one, right? This is the one that takes the ship datum and the ship redeemer. I'm looking for these indexes, but you know what? I think the way Aiken is built is that the indexes are actually going to show up in the blueprint file that Aiken creates. And this is another thing. We had some good conversations about blueprints and transaction building libraries. And so this is native to Aiken. This is one of, I think, its biggest advantages over Plutus TX is it's already got built in the generation of this file. And this can really help us think about what transactions we need to build. So we've got a set of validators. Each validator has a title, one or more datums, one or more redeemers, and some params. This is the spending validator. Deploy validator. Pellet. And here's space-time. This is where most of the action happens. And we'll want to implement all of this. But let's look here. Datum, there's one kind of datum, it's ship datum. There's a redeemer, ship redeemer, no surprise. And you'll see that the schema here is defined with a reference. That means we're going to be able to find it below in definitions. So let's go down to the definitions section of this file and try to find the definition for this redeemer. Past the minter, that's good. Definitions. Redeemer wrapper, ship redeemer. Okay, so the ship redeemer at the top level has an index of 1, so constructor 1. And then the fields are going to depend on which action we're taking. And it looks like those are further defined in another definition below. So let's keep going. Ship redeemer. Okay, Asteria redeemer can be index 0 or 1, in both cases, empty fields. And what can I do? I can add a new ship or I can mine. Pellet datum, pellet redeemer, ship datum. Ah, finally, here it is. Ship redeemer. 4 transactions, yep, with 4 indexes, 0 through 3. So as expected, moving ship is at index 0 with these fields. Gathering fuel is redeemer index 1 with a single field, the amount of fuel. Mining Asteria is index 2, empty fields, and quit index 3, same thing. How's this feel looking at this? Does this give you a good picture of this? And based on what you know already, something to work with as we start to think about transaction building? And obviously we need to get into minting. That's good, so we will. But this is a really nice overview, right? This file right here can serve to tell us everything we need to know about building this application. And we're going to revisit it over and over again as we start to create this. So now with that in mind, let's go back to the transactions once again. Those are deployed once again. Move ship is a transaction. Gather fuel, mine Asteria, and there's quit. So quit is going to have the redeemer, quit redeemer, which is here. And there we go. We see the top level index 1 and action 3, which is quit. And so if we find the same transaction for mine Asteria, we would expect the redeemer, where is it? There it is, yep. Top level index 1, action index 2, this time winning. And it looks like we are collecting from, yeah, look, here we're collecting from the Asteria contract. That's the rewards pot. And so you can see we're going to send the unclaimed rewards back to the contract. And where does collect from? I'm not seeing where these mined rewards get sent to the player. To address. I mean, we're sending something to the wallet address. Obviously, the pilot token. Maybe some lovelace. All right. Okay, so I have a question there. Oh, and look at that. Do you have to burn your... You have to burn your ship when you win? You get to the center, you burn your ship, and that's how you claim rewards? All right, I have a few questions here. A good place to start. And the really interesting transactions, the ones that we're going to be using the most often, are moving the ship and gathering the fuel. So I think the first transaction I'd want to build here, well, I guess the first one we have to build is creating a game and minting a ship. And then we'd be able to build this one. Don't even worry about the fuel or winning at first. If we could just create a game board that allows people to move around, we'd have to build the board, allow people to mint the ship, and allow people to move the ship. How complicated is this transaction? We collect from the ship UTXO. We read from the space-time contract. Yeah. We pay to the space-time contract with updated datum, output datum. And the value shouldn't change, right? The same amount of ship ADA and the same ship unit token. So, right, that's this asset, these two assets are going to be the same in the input and the output. And then, of course, we have to send the pilot token to the connected wallet, because in the validator, that token has to be included. But not too bad. And so you can see Lucid doesn't force us to specify inputs explicitly. That's a nice convenient thing about it. So just by saying, let's pay this token to this address, it's going to have found that UTXO and be sending it. But not too bad. There's our ship info, right? Output datum is the new ship info, which is the input fuel minus the spent fuel. That makes sense, right? It's the input coordinates with their changes. Same ship token name, same pilot token name. You can't change those. So this is the transaction. Let's find the validator logic. Got the transaction. Let's go back on chain. Base time. The redeemer, of course, is a ship redeemer. When redeemer is move ship, there's our redeemer. We expect a few things. The ship output has to be sent to the same address. Inline ship. Yeah. So we expect that the datum will be included in this UTXO, otherwise it's not a valid input to this transaction. Helper function calculates the distance, I'm assuming just as the sum of these two deltas. It would have to be the sum of the absolute value. That's why you can't, like, so if I was moving -5 in the Y direction and +5 in the X direction, that would actually zero out, but I really want the solution to be 10, right? So I guess these are going to be absolute deltas can sum those up. Distance, we have another util. Okay, so we're going to want to look at these util functions. That's great. Must preserve ship. Yep. So the ship input and output token amounts can't change. Same Lovelace, same token. Pilot token. Pilot token name has to be the same as the name of the output datum. That's going to ensure that only the holder of the pilot token can move the ship. Here's your updates, the position in the new datum must be equal to the input position and the delta. Update fuel, the input fuel minus the required fuel, which was just right here. And must respect max distance. Ooh, where's max moving distance coming from? Right? That's a parameter of this validator. So when we build a game, this could actually change the difficulty, right? Like the max moving distance in relation to the size of the board is, or I guess in relation to the minimum distance, right? Can make the game easier or harder. If we make a nice big max moving distance, then people can move a long way all in one UTXO. But obviously, if we make that a smaller number, it takes more transactions to move around. And that's a parameter. Cool.
Question, James.
Yep.
The moving distance is not related to the fuel that I have.
Yeah, exactly. Let's look at the picture again. Perfect question, because we do want to make sure to get that part right. So in this picture, like let's say the ship right here, right? And let's say I want to move 1, 2 spaces to the right and down 1, 2 as well. That gets me closer to the pot, right? So that would consume 1, 2, 3, 4 fuel, right? So the transaction here, if our input had some ship info, we're going to change the X value, in this case, by 2. And we're going to change the Y value by 2. And that means that our spent fuel is going to be a total of 4, which must be subtracted from here. And if we look at the on-chain code, let's see this exactly, right? So this says, look, the distance, and we should probably look at these utility functions right now. Let's do that. So utilities, we've got some Asteria utils here. Great. Off-chain. Where are the, oh, they're there, utils. Distance. Yeah, okay, as expected, right? Distance is just the sum of the absolute values of those deltas, right? So delta X or delta Y are going to be positive or negative because we need to know the directions, left or right or up or down. But why do we care about the distance? Because we're really looking at it in relation to required fuel. And so the distance is going to be the absolute value of X plus the absolute value of Y. And then we pass that to required fuel. And now fuel per step, it looks like that's another parameter. Let's look at the option. Fuel per step, look at this, is another parameter of this validator. So it's right, to me, it seems easy to make that just 1. You move 1 square, you consume 1 fuel, but it doesn't have to be that way. you can multiply it by this fuel per step param right here. And that's exactly what we see, right? Required fuel is the distance times this parameter. How's that feel? Cool. All right, so yep, those are helpful functions. It's nice that we don't have to rewrite those over and over again. Off-chain. Where are those used? Oh, right, those are used in the on-chain code. Okay, those are actually right. Aiken helper functions. What's the extension on those files? Utils. This says utils.ts. This is a TypeScript file. It says off-chain utils. Wait, okay. So there must be, where's the on-chain utils coming from? Oh, okay. We have utils defined in both the on-chain and the off-chain. Yeah. Ah, okay. Aha, okay. So the utils functions are defined both for the on-chain and the off-chain code. That's helpful to know. And so this is the exact same logic, but here on-chain utils are written in Aiken. Fine. Great. When redeemers move ship. Okay, so we've reviewed this. We do want to build that. And then once again, the transaction is here. I like it. Okay, so let's do this. I just started yesterday. Mm, Started a few new repositories for PPBL 2024. We have the front end template, which is we just replaced plutuspbl.io with a placeholder there. We've got some Plutus examples, which are just going to be used really early in the course. We've got our mesh live coding repo, and that's great, but I'm going to keep this one separate. Yeah, I want to keep that separate from this. So I want to make a new repository. And let's call this one, this is going to be a mesh Asteria demo app. Cool. And this is, I made this public, right? Public. Good. So this is where we can start this work. And for now, before I even pull this down, and I'll just add like a new T3 project to this today so we can use it. But let's just jot a couple of notes in the README right here. Okay, as an outline of what we do next, how does this sound? I think over the course of the next 2 or 3 sessions, this would be a really cool thing to work on together. Would you change anything about this plan or any questions based on what we just looked at? So before next meeting on 2024-05-07. Initialize project repo. And I'll take that. I'll make sure that's done. And then on 2024-05-07, build we'll try to build the first 2 transactions, initialize a game and mint a ship. Think I'll have one ready. So I'll have an admin token ready to go that enables this transaction. And then we'll try to build this minting transaction. This will be the main thing we look at next week. I like it. Thanks for spending the time this way today, guys. I didn't want to jump right into code without doing a little strategic thinking because I think this is a fabulous opportunity for us, and I appreciate you going there with me. Thanks. Here we go. I'm just going to take this as well and drop it into some reason. This is going to be a helpful repo. In the course, in both courses. Cool. So yeah, PPBL 2024, a growing collection of repos. We've got the front end right here. We've got the link to GitHub right here, which takes us back to where we just were. And now we've got 2 companion repositories, this one for Plutus TX, and this one, which is nothing more than a README, but over the next few weeks, we can start building it together. Awesome. All right, I feel excited about that. Any last words before we break for today? All right. Chris, let me know when you log in with Discord to Andamio, and I'll show you the quick next step. There's one more thing you got to do to become a creator.
Yes, I need to see what's going on with the Discord because it says that it's not verified, but it is. Same happened to me when I tried to log in into the Gimbalabs Discord, and Numa had to help me and give me access because it says the same, that I'm not verified, but I don't know. I don't know why. My account is verified. But I have no idea.
Um, let me know. I wasn't aware that we had that limitation on Discord login. I gotta look at how the Discord SSO works. All right, we'll take a look at that. But yeah, see what you can do if you can read these docs and just make sure that it sounds like maybe your underlying account needs to be somehow verified. But if you never have, if you have a phone that you can download Discord onto, it does make the login process easier.
All right.
But keep me posted. Let me know.
Okay. I'm gonna work on that right now.
All right, cool. All right, I'll see you tomorrow then.
Okay, James, thank you so much.
You
See you
bet,
tomorrow.
Chris. Talk soon. Bye.